So the most important part of this would be the definition of a function call, or how you use it. A function call consists of a function's name and its arguments. And then it says, or parameters, continuing the use of those terms interchangeably that I do. And it may return a result to the caller. So Python is what is known as a strongly typed language. I would have said it's a weakly typed language because the variables can change. You can store a string in one and then a float in the same one, and then turn it into an int, and then turn it into a turtle or whatever you want as you're going along. But the book definition of a strongly typed language is one that prevents you from doing things like this. String is equal to, pretend you don't need the word string, of course. And then if you did print x plus 3, a weakly typed language might print out Fred 3, right? Like that. And this is saying that it's a strongly typed language because it will not do that. I'd still pick up bones with it, but because you could have a language that was strongly typed, but the variable types, like numbers, had built-in conversions to strings. A module is a set of resources. You can import a module. A module is like the turtle file or the math file. Once you import it, you have access to all of the functions built into it. A semantic error, which is what I call a runtime error, occurs when the computer cannot perform the requested operation, as opposed to a syntax error. And a logic error just produces incorrect results. Now, when I say just, that doesn't mean it's not serious, right? If your logic error slams a 747 into the ground, well, that was a pretty incorrect result. Bad news. So a semantic error is one that just crashes the computer, or excuse me, the program, or reaches a state from which it cannot recover without your programming assistance. Because you can stop a semantic error from crashing your program, from killing your program off by using try except. And I think I demonstrated that. Did I use try except last week? Okay, all right. I want to go ahead and demonstrate a use of try except to get a number and to force the user to type in a good number, right? Not crash and not assume a default like we did last time, but to force them to give us a good number. And so it's going to use a loop, and it's going to use a function. And I'm going to call it getNum. Now I'm defining a function here. So def space get name followed by the parentheses followed by a colon. And this looks a little bit silly because it looks like it's setting up an infinite loop forever, while true, but we're going to have a return statement in the middle of the loop, so it will not actually loop forever unless the user is so stubborn as to never give us good input. So what we're going to do is we're going to do x is equal to input, and then we're going to convert x to a float on the next line. Matter of fact, we could do that all on one line, right, if we're trying to be all concise and stuff. X is equal to float, parentheses input, parentheses in parentheses, right, like that. I didn't make it print a message. I was assuming we would do something like this. Print enter temperature, and then underneath it, temperature equals getNum, something like that. I was assuming that we would print the message beforehand. But we could also make it accept a message right as an argument to the function, right? We could do that. We could cut this, put that there, but then we would have to add a parameter that would accept that argument. So I'm going to change that to MSG. It's accepting. This is the parameter variable that accepts this argument. And we're going to use that to fill in the optional argument to the input function, which we know what that does. That just prints out the message as it's asking for the input. All right, and then we're going to have a return X there. Now I forgot something. I forgot to put the try and the except. So I'm going to have to do a little bit of extra tabbing. Here, I'm going to do try colon. I apologize for forgetting that, and I need to tab both of these guys over. And then lined up with the try is going to be the except. This is what's triggered if they type in bad input that cannot be converted into a float. Print error. That is not numeric. Something to that effect. Print parentheses quote error that is not numeric end quote in parentheses. And that's the end of the function. It looks kind of weird to end the function, you know, all dangled over like that, but we don't need anything else after it, right? Because our return statement usually goes at the end of the function, but I wanted it here so that if the conversion was successful, it would immediately return the value. And if the conversion was not successful, it would trigger the error handling. But I'm going to go ahead and add a comment that says end while right here, just so that it doesn't quite look so lonely. Like that. Necessary? No, not at all. And if you're familiar with the idea of a break statement, we could have used a break rather than a return there and then put the return at the bottom. I just wrote it in as few statements as possible. And since we haven't really talked about loops all that much yet, I'm not throwing in break statements. Lecture F, I presume? Wow, okay. Yep. All right, if you have to run out the room early, there's a Dropbox. All right, I didn't test mine. I just assumed it worked. Why don't I test it? All right, enter temperature. Now, it's kind of cheesy to have the cursor right there, but, you know, if I type in 10, great, it succeeded on its merry way. If I run it and I type in bad input, it yells at me, error that is not numeric, enter temperature. So, we have gone a long way towards making our program safer to use, right? It will not crash if they type in bad input. If you were so inclined, you could copy and you could paste this into every single function, every single program you write from now on that asks for numbers. Right? Then you would never have to worry again whether I was going to ask you to write a function that would or would not crash based on bad input. Let's do something with the number just to prove that it worked. So print parentheses quote, you entered, end quote, comma, temp, in parentheses. And I don't like the cursor being after the word there, so I'm going to change this a little bit more. So before I print the message out, maybe I'm going to add a colon to it. Message plus equals colon space end quote. That's a bad idea because it's going to add more and more colons every time, right? That's dumb. So I'm just going to fix it by going down here and adding a colon and a space right there. I mean, that would have been slightly amusing to do. Let me show you what it would have done. Looks great, huh? Ah, I didn't mean to type in right data. I wanted you to continue to see how it failed. What it looked like. Kind of like it. but not really. It's like it's getting impatient, you know. But nah, we're going to get rid of that. I don't want to change the message every loop. Oh, I could have changed the message one time before we go into the while loop. So, if you made the change that I temporarily had made, where I put a colon here, you can take that out and do message plus equals quote colon space end quote right there. Remove it from there. All right. Was all that strictly necessary? No. But that's where that colon finally wound up being. I took it out from there, and I didn't put it there. All right, we are done with that chapter. This demonstrates a function. The function is called getNum. It has one parameter variable. We filled the parameter variable in with this argument. It has a return statement, so it is a fruitful function, to use a term that I believe the 1113 textbook uses. Okay, so say that we like this function so much that we wanted to start using it as a library. So I'm going to do new file, and I'm going to save it as lecture G2. The first statement is going to be import lecture G, because I want to use it as a library. Import lecture, guess I better capitalize it correctly. Lecture G. And then when I'm ready to get that number, I'm going to do weight equals getNum parentheses quote, what is your weight question mark, end parentheses. Excuse me, end quote, end parentheses. This is not going to work, though. It's going to be an error. Two things are going to be wrong with it. Why don't I fix it rather than demonstrate, you know, what's wrong with it? I need to put in lecture G. And if you put a space in your file name, it's not going to work. So, roll with me for just a second. This is how you import something and then use something from the module that you imported. Right? This had to match this. What if I didn't like typing this up at the top? And by the way, really, if you did save your file name with a space in it, none of this is going to work. Let's prove that this works, though. All right, enter temperature. What? I wasn't asking about temperature. I was asking about weight. You entered 89.0. What is your weight? Okay, well, at least it finally got to it. What has happened is that when we did the import, it ran all of this code doing the definition of the module, of the function. Great. But then it went ahead and executed this. That import causes it to effectively copy the entire contents of this module and to come over here and paste it there, like that. That's what it did when it did the import. And you see that our new code showed up right there. We didn't want that code to show up. We just wanted to use the function. There's a way you can fix that, which is to put absolutely everything inside your module, inside functions. Well, then how would it work if I wanted to run it alone, right? Because if I put this in some kind of module called main or something like that, that looks great. Not going to do a darn thing. Work for the C language where everything has a main function. But now that we've done that, this one works the way we want it to do, the way we want it to go. Or not.
You deleted your import function.
I deleted the import. Thanks. All right. And so it only asked me for my weight, and I'm feeling good. All right. It works. But I cannot come back over here and run this one anymore. I've broken this code. And maybe honestly, you wouldn't have that many times where you would be writing both a program and a module at the same time. Right? If I load up turtle.py and run it, it's not going to do anything. It's just a module full of functions. But say I really would like for this to work. I would like for this program to work, but I'd also like it to be able to be imported into another program. Well, I need a way of calling main then. And so here's what we're going to do. Down here at the bottom, we're going to write, and the syntax has to be absolutely precise or it won't work. And when I do these underscores, they are pairs of underscores, underscore, underscore. So if underscore, underscore, name, underscore, underscore, equals, quote, underscore, underscore, main, underscore, underscore, end quote, colon. If that is true, if the name that we are running in is equal to main, then call our main function. And it's okay if you don't totally get this the first time. We will be doing this again. Now it will work, unless I've made an error. All right, enter temperature. So that one works. I can type 56 and have it work. And then if I load up the other program over here, it also works. So really, all of the programs that I write in this class and demo for you ought to have this code. Everything ought to be inside a main function like that, and then I should have a trigger down here that indicates what it is. So what is this business anyways? What is this underscore underscore name? We didn't create that variable. You're not allowed to use variables before they're created. Where did that come from? Well, let's print out the value of the name variable. Up at the very top, maybe. It's a built-in variable. Print, parentheses, quote, parentheses, quote, name is, end quote, comma, underscore, underscore, name, underscore, underscore, end parentheses. Like that. When I run it, it says name is underscore, underscore, main. All right. So that is a variable that is created by Python, not by us. I'm going to move that statement. I wonder if it's going to say main when I run it from over here as well. No. When I imported it, though, this variable became lecture G. It's kind of weird, but by the act of importing this module, when this module got copied into here, the value of the variable in this file was no longer underscore underscore name. Over here it still is. But that's why this is able to work. Because if you get to this point right here, and we are running this program, if we ran this program with run module, then this built-in variable will equal that very specific name. However, if we import the module, that variable is going to equal something different. It's going to equal the name of the file in which it's stored in. So, do you need to remember that? No, but I'm going to demonstrate this bit over and over and over. And it's okay to ask me later, again, to explain why it's working and why we do it. The way we do it, the reason we do it is so that we can take the code that we write and then import it into another module, into another file, without it automatically triggering the code. Because I don't want it asking for the temperature every time I bring this in, right? I only wanted to ask for the weight. Anybody got syntax errors? I would like for this to work for y'all. All right. Two underscores. It's weird, but you got to have two underscores on each side. Including on that and on main. Seems a little bit overzealous to me, but that's how they made it work. And the same up there in the print statement. Anybody else? Okay. Two underscores on each side. I didn't make that clear enough. Well, when I said two underscores, a lot of people thought, oh, we've got two now. It's a total of 4. You're going to have to do it there and there as well. All right, if everybody's getting the error about name is not defined, note that it's 2 underscores on each side for a total of 4. So there's going to be 4 underscores there, there's going to be 4 there, and there's going to be 4 there. Go back.
And I've got 2 underscores on each of them.
Okay, yeah, go ahead and run it.
But I'm not getting an error. What I'm getting is something on that.
Y'all are both using Notepad and it's behaving weirdly for both of y'all? Is that what I'm seeing?
Syntax, EOL,
I did the syntax.
scanning,
Oh, okay.
string literal.
All right, but that just means that you are missing a quote. Put a quote after the question mark.
Oh, yep. Okay, now I get some.
So run this one separately again. Let me just see what it does, yeah. Oh, I see it. Go back. Just close all this. We don't have main defined. I went too fast on that one. And no wonder, because this is halfway up the screen. There, like that. These 2 lines need to be in a function like that.
So how come,
Right there.
how come on the second one it's not? So it will.
Okay, go ahead
Okay,
and run
you
it.
see that one, def getting them, line below that one, colon.
These need to be saved in the same directory. Go show me the first one.
No, you don't need the
Section
second
G,
one, just make it.
there.
Well, I know, but I mean.
Is that in the same directory?
Did you do it the other one though?
Right.
Yeah, that's what I see.
I mean, I changed the name because there was a space there.
Okay, that's
So
cool.
Would that affect anything?
Well, it should work once you did that. Go ahead and show me that this one runs again.
Yeah,
You don't need the,
fine.
wait, the,
I don't know what that.
no, you don't need that at all.
All right, come over here.
Yeah, I had.
Yeah, it's not
G2
defined
one.
before it reaches
12
that point,
Oh,
so
I found it. Okay.
it's kind of,
No E.
for lack of a better way of putting it, it's like asking
Yep,
it
there
to
we go.
define itself.
Oh, okay, cool.
It's misspelled.
Amazing how one character missing or out of work the entire
I
base.
probably
Especially if you spell
wrong,
something else.
but it's,
All right, let's,
take the benefits.
Or what?
Yeah, that's kind of what you're saying. Yeah.
Yeah.
His brother.
Yeah.
That's the easiest way to go about it. I mean,
Couldn't find where it was, so basically.
Yeah, just do-
Can you move things
because
like
in the lower, it's easier than right.
Really?
I'm actually on truth that made it a new type of way.
Like, I know you for sure you can, but I don't remember how.
Is there no way of getting a new one?
Do I need to
I
make
broke it
this?
back down
Yeah, I'm
to-
putting them all
Do I need to
in.
make this all
Right.
spelling instead of putting spaces in between? Is that why it's saying it's invalid syntax?
I wonder who did
This
this.
is why, take plans for Blue.
What?
And then put it like,
I'm happy with what we have.
That's certainly not gonna work when that happens, but I wonder if it'll at least
Not,
get
you
you
know,
one
it's not
station
your
going.
part of punch cards.
No, yeah, this file would have to be
just make it one,
one
like,
file.
okay.
And it's okay if you don't get it running. You can just go back, and we're gonna make all the rest of our changes to the original one anyways. If you named your original file instead of lecture G with no spaces like I did, if you gave it a name with spaces, it's not going to work. When you try to run it over here, the import statement will fail. I don't know how to correct that. You could rename this one, but I wouldn't bother. I don't think I'm going to keep adding on to that one. I'm going to keep adding on to our original file, our first one. Yeah. That's correct. That's what it's supposed to do. When we imported it, it brought this code in and it
Or
turned it out
just
to
make
be
make sure it shows up.
Exactly. right, so experience on my part. I need to remind everybody at the very beginning, if I'm going to go in this direction, that this file name had better not have any spaces. But I am going to use this syntax more often. So you might want to switch over to the mode of naming your thing with no spaces, and if you really like spaces, using underscores. So I'll try to remember that in the future. Maybe I'll demonstrate it by doing lecture underscore H next time, something like that. Had another incredibly important comment to make, and I don't recall it now. Oh, our import statement. What if you didn't like doing that? Especially what if the file name was, incredibly wrong by Jeff Thompson for CIT. Okay, right, you get the idea. It would be, don't make that change. It'd be really annoying to do that, right? Instead, you can use import from. So, from lecture G, import, the name of the function is getNum. And then I can use the function without putting its name in front of like that. Cleans it up a little bit. And that way, if we didn't really have a long file name, right, at least we wouldn't have to put it everywhere. We just have to put it, right there. If you want to bring in every function inside the file, you do import star. Or you can pick and choose, like I just did when I said getNum. And if this chunk of code isn't working because you had spaces in your file names, it's okay. I'm going to come back and make the rest of my changes to here. That code.
If you just wanted to import like 2 or 3 of the items from a file, just put commas to them?
I don't know if that works. Let's try that. Import getNum comma main. Is that good syntax? Cool. You taught me something. Yeah, you can list. Yeah, you can list all. Apparently, you can list all the functions that you want to run using that syntax. Neat. Thank you for asking that question.
You guys wanted to do that, or if you had to do separate import?
In the past, I've been doing separate imports, and yeah, in the past I've done separate lines, separate imports, and you can do it that way, or you can do just import asterisk and get them all. Cool. Alrighty. Loops and selection statements. I don't recall from this book whether they mentioned anything more than an if statement, because if is the only selection statement that I know about in this language. If you've done Java programming or C programming, you're familiar with the so-called case statement, switch and case. This one does not support that. So, looping is repetition. Just repeats a statement over and over and over, like in our code. If we entered bad data, we wanted it to loop over and over and over, right? Forcing the user to enter good data. So it had to print the message again, and it had to do the input statement again, and it had to do the float statement again. Every repeat of it is known as a pass or an iteration. That's the term that I use. Pass is a great term too. If it asks for it in the quiz online, then sure, click pass, but I'm never going to use it. So there are 2 types of loops. Those that repeat an action a predefined number of times, and those that perform an action until the program determines it needs to stop, which is known as indefinite iteration. Definite iteration is going to run a specific number of times. I want this loop to run 10 times. Indefinite would be I want it to run until the user types in a queue. Oh, they snuck this in. This is kind of cute. That end bit. Let's play with that. I'm going to go back to my original file with all this. I'm going to start adding things above this. Temp is equal to get num, just because I don't want to have to type in something every time to see it work. So, for x in range, parentheses 4 colon. In other words, repeat 4 times. When x starts, it's going to equal 0, and then it's going to be 1, 2, and 3. Tell you what, I want to use a while loop. I'm going to erase that statement. X equals 0 while x is less than 4 colon, print, parentheses, quote, it's alive, exclamation point. This is silly, but whatever. I did put a space there between the quote and the exclamation mark. And then on the next line, x plus equals 1, or x equals x plus 1. What's that going to do? It's going to count x from 0 up to 3. So it's going to print it's alive 4 times. 0, 1, 2, 3. And then when x finally equals 4, it's going to exit the loop. The for range statement that I had would have done the same thing. But I don't want to throw in words like range before I have to at this point. Okay, so it printed it's alive, it's alive, it's alive, it's alive. Now the book showed a little fancy thing they snuck in called the end argument. Go here on your print statement and make it say end equals quote, quote. It's alive, it's alive, it's alive, it's alive. What it does is that the print statement by default goes to the next line after every call. And we've seen that. As though it were written like this. \n means go to the next line. But we can override that \n by putting something else there. If we don't want it to go to the next line, if we would rather print smiley faces, then we could do that. Now, obviously, you don't want to print smiley faces, but sometimes you want to print, multiple pieces of data on the same line with multiple print statements. Notice, though, that when it finally got to enter temperature, right, it was still on the same thing, still on the same line. So you would probably want to put a normal print, an empty print, right there. Now it'll look okay again. No. Ah. I'll show you the error. You tell me what I did wrong. Unindent does not match any outer indentation level. Print needs to be backed up 1. It looked like I lined it up to my eyes, but I didn't. All right. So, the end parameter, like that, could be useful for that purpose. Well, what purpose? Well, what if you want to print out a series of values? What if you want to print out the numbers 1 through 10 all on the same line using the same technique? I'm going to set x equal to 1, x equal to 1, and then while x is less than 11, colon. I know that looks slightly odd. You're expecting me to do while x is less than or equal to 10. Just roll with me for a minute. And then print, parentheses, x, comma, end equals, quote, space, quote, end parentheses. Like that. Then the next line is going to, again, be x plus equals 1. X plus equals 1. And then I'm going to back tab so that I can have my final print statement. Why do I want a final print statement? Because this never went to the next line. It's like we typed a whole bunch, but we never hit enter. So we're going to hit enter there. And there it goes, right? It printed all the numbers. In the past, if we'd done a loop and had print statements without that end parameter, it would have just printed them all on top of each other, right? 10 print statements in a row. This time, it printed them all out in a line. If you want it to behave that way, that's how you do it. Something all of a sudden nagged at me. I know that there's a way to format a print. Nah, I can't come up with it. Never mind. All right, so this shows it going from 0 to 3. We don't see the value of x, but it's there. I'm going to comment out it's alive and just make it print out x like I did here. I'm going to take that statement, copy it. I'm going to come up here and either comment out or just replace that one. I think I'll there, you see what I did? I took that statement from the second loop and I just tacked that on there. Why? Just so I can see the numbers print out. All right, and it printed out 0, 1, 2, 3. So, starting at 0, going less than 4, it makes it do 0, 1, 2, 3. Starting at 1 and making it go less than 11 makes it go 1 through 10. Why did I bother showing you that? Because we're going to do the same thing but with a little bit less code. I'm going to repeat the functionality of this one. For x in range 4, parentheses 4, end parentheses colon, and then we need that one of those print statements, the print x equals end. And then we need one final print statement there. I'm just going to add a comment as to what that's going to do because it's going to print out 0, 1, 2, and 3. And it did. It printed out 0, 1, 2, and 3. That's what the range statement does, is it generates a series of numbers for it to iterate through. What's the difference between this loop and this loop? We didn't have to initialize the variable, and we didn't have to increment the variable. When you use this syntax for x in range, it initializes the variable, and it increments the variable all for you. Well, what value does it get initialized with? 0 by default. If you only give one argument, it defaults it to 0. But what if you wanted to start at another number like we did here? What if we wanted to go from 1 to 10? Well, I'm going to copy this. Come up here and paste it. And since I wanted to start at 1, I'm going to put a 1 there. And since I wanted to stop at 10, I'm going to put an 11 there. And you go, wait a minute, why are you putting an 11 if you wanted to go to 10? Because it runs until it hits 11. So you actually have to go one past your stopping point. Kind of weird. But if we put 4 here, it's going to go 0, 1, 2, 3. And it's going to stop when it hits 4. If we put 11 here and 1 there, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then stop. You just have to remember that this is one past the number where you want it to stop. You want it to go out to 1,000, you better make it 1,001. If you only have one argument, that's the stopping point. If you have 2 arguments, it's the beginning point and the stopping point. Then you can add an optional third argument, which is how many to skip by each time. Well, this comment is completely wrong at this point, right? So 1, 2, 3, or I'm just going to say 1 through 10. It's easier to type. What if we wanted to count from 10 to 20 by 2s? I'm going to take all 3 of these statements and copy them. And paste them and change the numbers so that they print out 10 through 20 by 2s. So I wanted to start counting at 10. So I'm changing that to a 10. I wanted to keep going up through and including 20. So I need to make that 21 or 22. And I want it to count by 2 each time. Not just add 1 to it each time, but 2. And so now this comment is again wrong. Right? It's not going to print 1 through 10. It's going to print 2 through 20 by 2's. And there's nothing magical about 2. It could be by 10s. It could be by negative 2's, in which case it'd be counting down. And it did. 10, 12, 14, 16, 18, 20. So if you have been playing along and typing all this stuff, copy and paste that and change it to print from 100 to 1000 by 100s. Make it start at 100. Make sure it'll stop after it hits 1000 and make it go 100 each time. And if you have syntax errors at this point, go from 100 to 1000. But correct, that is wrong. Thank you. Right, if you're going to add, so when you do the 100 to 1000, let's go by hundreds. So for x in range, what's my first number going to be? 100, and I want it to stop after it reaches 1000, so that would work too. Anything after 1000 would work. I'm just going to go ahead and roll with that, but putting 1100 would be equally good. Then I'm just going to copy those 2 statements and paste them. (100 to 1000 by 100s). Next, we're going to try making it count down. I want it to go 8765431. So I'm going to copy that, paste it. It's going to start at 8. And this is wrong, by the way. 1 is not the correct answer. But I want it to count down by negative 1's. Somebody hazard a guess as to where it's actually going to stop. It's going to stop at 2, right? Because when it reaches 1, it's going to kick it out. So I'm going to need to make it up to 0 if I want it to actually get down to 1. You always got to go 1 past, regardless of which way you're going. If you're counting up, you better make it 1 greater. If you're counting down, you better make it 1 less. So this is from 8 to 1 by negative 1. The range statement is such an easier way of writing accounting, not accounting, but a counting loop, that you will never see me do it like this unless I have a really, really, really strong reason for doing so. Now that you've seen the for x in range statement, I'm probably not going to use while loops nearly as much. But of course I want you to have the idea of while loops as well, that they're the simpler form of loop, the fundamental loop. Every programming language has a while loop. Not every language has a range statement kind of syntax like that. If we were going to write this statement right here in another programming language based on the C syntax, C, C++, Java, things like that, it would look like this. You absolutely do not have to add this comment. Whoops, I copied way too much. But it would look like this. For, parentheses, x equals 10, semicolon, x is less than 21, semicolon, x plus equals 2. That's the same syntax in other languages, many other languages, as that. They're the same functionality. I kind of like this syntax in a way, but that's because that's what I originally learned. And when people write this syntax, they usually don't make it less than 21. Instead, they make it less than or equal to 20, right? Because that's the way our brains work, right? I'm going to go from 10 to 20. And as long as you remember to make it equal to there, then it works. But we don't have that option in our language of choice here. We have to put 21 to get it to work perfectly, or 22, right? Either way would kick it out at 20. So this is telling us the syntax of it in a very difficult way to read. That should be a lowercase f. The less than and the greater than are not actually part of the syntax. They're just something that's supposed to be filled in by us, right? Like for x in range. And then an integer expression. Well, it can be more than one integer expression, right? It can be 2 or 3 numbers, as we've seen. But if you have one number, it defaults counting at 0. If you have 2 numbers, it starts at the first number and stops when it reaches the second number. And if you have 3 numbers, it's the beginning, the end, and then the increment. I don't particularly feel like doing that one, but we'll do a adding loop, a summation loop, and a factorial. Summation is when you add all the numbers between 1 and 10, and factorial is when you multiply them all out. So I'm still in this main here. So to count summation, we need an accumulator variable, something that's going to hold our total. I love the variable name sum, but it happens to be a function name, right? It turned purple as I typed it, so I'm not going to use that. I would in any other language. In this one, I'm going to use total. So I'm going to set total equal to 0. Then I'm going to have a loop. I want it to go from 1 to 10, so I'm going to make it range 1, 11. For x in range, 1, 11. For x in range, parentheses, 1, 11, in parentheses, colon. Total plus equals x, or total equals total plus x. Now let's print out x in our current our current total. Print x equals %d, comma, total equals %d, end quote. And again, this syntax gets a little bit weird. %, open parentheses, 2 close parentheses, and then go back and move your cursor between those two. And we're going to print out x and the total there, x comma total. Yeah, and there it goes. I'll bring the code back. Sorry guys, covered it up. So I ran it and we see that when x was 1, the total was 1. When x was 2, the total was 3. When x was 3, the total was 6, or whatever. It's just adding all the numbers together. So the summation of 10 is 55. How about the factorial? The code for a factorial would be almost the same, except I would make that a multiply rather than an add. And I better not start it at 0, right? Because 0 times 1 is 0, times 2 is 0, times 3 is 0. So I'm going to take this code here, copy it, and I'm going to change the word total to fact or factorial. And I'm going to start it at 1 rather than 0. So copying all that, pasting it, and I'm going to change each occurrence of the word total to fact, standing for factorial. I'm just going to delete that comment. All right, now to make it factorial, which is multiplication, I need to make the 2 changes that I mentioned. It's going to start counting at 1 rather than 0, and instead of add equals, it's going to be multiply equals. So start factorial off at 1, change that line. And then where it says plus equals x, make it multiply equal x, star equals x. So change that line as well. And you'll see when you run it that the factorial gets very large very quickly. The factorial of 10 is 3 million. What if we want the factorial of 20 as opposed to the summation of 20? Let's change both of these to 21 rather than 11. Yeah, that factorial is big, right? The factorial, the summation of 20 is just 210, but the factorial is quite large. What about the factorial of 100? Just out of curiosity, I'm going to change this to 101. I want to see if we can get to the point where it breaks the language by getting too large of a number. Nope, seems happy to keep churning along. How about 1,000? Well, what do you know?
612 promo.
I hit Control C to stop it. So we were at x equals 622 at that point.
Wow.
Large number. All right, I'm going to undo that change, right? Augmented assignment. I like that, augmented. Other books have called it compound assignment operators. That's when you use both the equal sign and a symbol like plus, minus, star, divide. And we've been doing this all along. X plus equals 3 is the same as A plus equals 3 is the same as A equals A plus 3. A minus equals 3 is the same as A is equal to A minus 3. It's just a shorter way of writing it. A modulus equals 3 is the same as A equals A modulus 3. S plus equals there, takes there and adds it to S and stores it back to S. So it's equivalent to S equals S plus there. Off by 1 error. If we want it to count from 1 to 4 and we put 1 to 4 there, it only gets up to 3. Not a syntax error, but a logic error. Yeah, sure, why not? Let's start talking about lists before we're ready to. What is a list? A list is a sequence of values separated by commas. Like this. I'm getting tired of putting stuff at, well, I guess I better put it here because otherwise it gets scrolled off. So, L, capital L, because it makes it easier to differentiate between uppercase I's and number ones or whatever, is equal to, and then a pair of square braces, and we're going to put some numbers here. 8, 6, 7, 5, 3, 0, 9. Classic rock fans recognize that phone number. And then for x space in space capital L colon, for x in L, print parentheses x. And it did, in fact, print out 8675309. This is a list which your textbook for 1113, if you took it, called it an array. Python does not support arrays as strictly defined in other languages such as C and C++ and Java. The difference between an array and a list is that an array is fixed in length. And once you define the length of the array like that, you can't add items onto the end of it. And you can't remove items from the middle of it. An array does not grow and shrink. However, lists do grow and shrink. And so they are so awesome that the inventor of Python didn't even bother to implement arrays in the language. He just did lists. And so pretty much you use them conceptually the same, because lists are more flexible than arrays. And everything you could do with an array, you can do with a list as well. What if we wanted the sum of that number? Two ways. One is we could write a loop, or we could just call the sum function. Total equals sum, parentheses, L in parentheses, like that. Or you could do it long form, like we did up here when we were calculating the total between all the numbers of 1 and 21. Total equals 0. For x in L colon, total plus equals x, like that. It wasn't that much harder, right? But if you can do it in one statement, why would you want to do it in 3? So check out this syntax. This is the same as the first part of it was the same, right? For x in, right? What differed is here. This part can either be a list, like it is here, or it can be a range. The list could even be defined right on the spot, like this. For x in, and then some square brackets. Red, end quote, green, end quote, blue, end quote, like that. And then a colon to indicate that we're tabbing, and then print x. Yeah, perfect. Pondering whether to go into how you would access it as though it were an array. And I guess I will. I'm going to create a list variable called names, and I'm just going to stick some Thor, end quote. Iron Man, end quote. Ant-Man, end quote. Deadpool, whatever. I want to print out the first element of the list. Not all of them. I'm not using a for loop. I just want to print out the first element of the list. Now I know somebody already knows what number I should put between the squares to get the first element. A 0, right. That needs to be a 0. It's called zero-based indexing. It's why I have a homework 0 rather than a homework 1 to begin with. That's 0, that's 1, that's 2, and that's 3. Just like our for loop, right? Always started at 0 unless we told it to go somewhere else. I feel like changing the last one from saying Deadpool to something else. Print parentheses. No, I'm not going to print it. I want to change it. We're going to jump from movies to TV shows. So this is going to be Daredevil. Name subscript 3 in subscript equals Daredevil. And now I'm just going to print the list. All just in one fell swoop, not even with a loop. I'm just saying print the entire list. And so it's going to print Thor, Thor, Iron Man, Ant-Man, and Daredevil. Which it in fact did. So this is treating the list as though it were an array. This is how you access elements of an array. This is called the index value. That 0 is an index value. That 3 is an index value. The index value, and this is so important that I'm going to put it in as a comment. The index value of an array / list goes from 0 to n-1, where n is the length. So if the length of the list is 4, we can go 0, 1, 2, 3. If the length of the list is 100, we can go 0 to 99. Just like that range statement, right? We wrote range parentheses 100, and that would count from 0 to 99. This is showing us that you can create a list from a range if you want. This will be about the last thing we do. Capital L is equal to list parentheses, range parentheses, starting at 10 and going to 20 by 2, so it'll be 10, comma, 21, comma, 2. And then we need 2 close parentheses because we had 2 open parentheses. Oh, and I didn't do anything with the numbers, so we don't see it right, but it worked. So let's print out the numbers of L. Just do print parentheses L, like that. (10, 12, 14, 16, 18, and 20). So we created a list from a range statement by using the list function. The list function takes whatever inside it, and if it possibly can be, it's converted into a list. This would not work. We could not do this. Now watch it work and prove me wrong, but we could not do L is equal to range 10. This is going to break, so I wouldn't even bother typing it. And have it work. Please tell me it's not going to work. Well, it did something, but it didn't do what we wanted it to do. It didn't make a list out of it. It did not make a series of numbers out of it. So to make a series of numbers out of it, to make a list, to make an array, we had to do it that way, using the list function. So let's add a comment to that effect. Converts the range into a list. All right, we're going to need homework. So write a loop that prints all the numbers from 100 to 200. Do the same for 100 to 200 by tens, right? 100, 110, 120, etc. Write a loop that will count from 200 to 100 by negative tens. Declare a list named books that contains the name of 5 books. Or if you like movies better than books, and then use a for loop to print out all the books. Change the first book / movie to something else. Remember to use index 0. And then use a for loop to print them again. And then lastly, calculate and display the sum of all the numbers between 1 and 1,000. Now we've done examples of every single thing on here. But of course, if you get stuck, go ahead and ask for help. I'd recommend going ahead and looking at it tonight or tomorrow night so that when you come in on Thursday, you could ask questions about it. But it's also always cool to text me over the weekend or whatever. All right. We have a Dropbox. I'll bring that back up in a sec. This is slide. That's where I want to stop, which is page 14.